Boo! Hi everybody and welcome to another exciting edition of Boring JavaScript. I'm your host, the Virtuoid, aka Mike Smith, and today we're going to be talking about generator functions. Oh, I have been waiting months to be able to do something on generators. So what's a generator function? It allows you to build your own iterable. What's an iterable? Well, let's think back to arrays for a minute. Now, you know you have methods on arrays like for each or map or filter that basically goes through each and every single element of the array. Now that process of going through all of the elements is called an iteration. And the mechanism that goes through that iteration is an iterable. So internally, JavaScript will go through your array using an iterable. And that's what generator functions allow you to do. It allows you to build your own iterables, which is a real powerful way of being able to expose anything you want to a consuming application. And that consuming application thinks it's just a simple iteration. Want to see how it works? Let's get started. Now, generator functions are real easy to use, but they have a couple extremely important concepts that you need to understand before you can effectively use them. And let's go through those in a couple places here. First of all, the construction of the generator function. To declare a function as a generator function, all you have to do is put an asterisk by the word function, and that's it. And what that will do is that will tell JavaScript that this is a generator function, and it will immediately return a generator object to the calling program. Now, it will not execute the function itself, and that's real important. Now, you're used to when you call a function, like I have here on line 7 here, when you call a function, it will just execute the function and then return something. Generator functions don't work that way. A generator function will immediately return a generator object to the calling program and await further instructions at that point. What the calling program will then do is that it will call a next method. And that next method will then tell the generator function, okay, I need the very next value that you want to give me. And that's critically important here because remember, the generator function is a custom iterable. And an iterable needs to be able to return some sort of value in an iterable fashion. Just like an array, you return the first element, then the second element, then the third element, and the fourth element, and so on and so forth. You've got to do the same thing here with the generator function. And how that occurs is with the yield statement. So let's take a look at that. Here are the yield statements in here. In this case, I have 3 yield statements. And what will happen is that the very first time that next is called on the generator function, it will at that point execute the function. The minute it hits a yield statement, what will happen is that the generator function will return an object back to the calling program. That object has 2 properties. The first property is the value that gets returned. And in this case, I'm going to be returning cat, then dog, then horse. And for the very first case, cat. And that can be anything. Doesn't have to be a string. I just threw a string inside there. But the second property is a done property. And that done property is either true or false. False if you're not done, and you can continue on calling the word next to get the next value, or true, which means, hey, we have nothing left. But the second most important thing here to remember about generator functions is that when the yield is hit, what will happen is that that value is passed back to the calling program and the function is suspended. It doesn't end, it is suspended. It's just like you're just kind of going along in your function and suddenly you just stop. But you don't return. You don't just stop the entire function, you just stop the execution, you suspend it. And so what will happen is that we call this first next here and we get the cat. When we call this next time, we call the next, it will then go back into the function and resume execution from where it stopped off. So the first next will yield cat. The second time we call next, which is here on line 10, it will begin execution after the yield cat until it gets to another yield. In this case, yield dog. So the second time it does the next, we're going to get dog back. And again, the yield will suspend the operation of the function and just stop at that point. So the second time we go and call it, it's going to be next. We're going to get back dog with a done flag of false. And we'll tell you here in a second how we know it's going to be true or false. And then we do it again. We're going to get next again. That's going to give us horse. And then we're going to get next again. But notice once we get back into the function, there is no more yield statements. So what happens when you get to the end of a generator function? Well, what happens when you get to the end of a function? If you don't have a return statement, it will automatically cease the operation of the function. It assumes a return statement. And what will happen within a generator function is that if you get a return statement, that is the signal that everything is done. So what you'll get back is the done property set to true, which is why we can just say while not animal dot done, and just continue on that loop with line 10 there until done becomes true. And done will become true the fourth time we do the dot next, because there's an implicit return there. And I'm going to show you that a little bit more. So once we execute this code, we should be able to get all of our different functions. So to kind of show you how everything works, I've got another version of the program here, and I've got a ton of console.logs. Oops. There we go again. I got a ton of console.logs there to kind of help show you what's going on there. We're going to start with the begin and we're going to end with the end. I'm going to say initialize generator after I do my animals. And the reason I'm going to do that here will be played in just a second here. And then I'm going to console.log what the current animal is, and then I'm going to console.log what I expect the next animal will be. And that's where we'll see the done flag. So if we execute this code, let's flip over real quick, and we just type in node yield. There's our begin, there's our initialize generator. This is the first next, which was the cat. The next was going to be a dog, which is a false, so we print out dog. The next one is a false for the horse, so we can print out horse. The next one, the done, is equal to true. And it's equal to true because we hit that return statement, and then we've ended. So let's do a couple of things here to prove. Earlier I said that the function is actually not executed function until the very first next is called. And so what I'm going to do here now is I am going to put a console.log here inside my animals function. And normally if I call my animals here on line 9, normally it would just execute the function. I should see executed function right after begin. But with the generator function, the function itself is never executed until the first next is called. So what will actually happen now is I should get begin, then I should get initialize generator, then the next is called. At that point, I should see executed function. So let's check that out and make sure it works. Let's go over back to here. Let's clear off the screen, and let's go to yield. Yep, sure enough, it's exactly what happened. This proves to you that the generator function does not actually execute the function until that first next is called. So, because you can see we got the begin, the initialize generator, and then the executed function. Now, also earlier I said the return statement basically tells it that the operation is done and there's nothing left to do. So if we were to put a return statement, just a simple old return, after dog, then we should expect cat to come in and dog to come in, and then that's it, because we never got to horse. Once we hit the return on a generator function, as far as it's concerned, the iteration is over with and it sets the done flag. So let's flip over to node, and let's clear off our screen. So now we should get cat and dog. Sure enough, we just got cat and dog. So that proves to you that a generator function, again, gives us an iterable that allows us to very easily go through each and every single one of the iterations within the iterable. And it also shows you that the function is not executed until the very first next, and that any kind of return statement that it occurs, either the end of the function or somewhere within the middle of the function, automatically signals that the iteration is done. Now next, I'm going to show you a real-life example of a iteral in use to be able to take just an awful data stream and to normalize it. That's next. Okay, so why would you want to build your own iterable? Well, one of the great things about building your own iterable is that if you have, let's say for instance, a database which is just a cacophony of just the weirdest data you've ever seen, and you've got to be able to normalize the data from that database, you can use an iterable to have your calling program just say, okay, give me the data, give me your next one, then your next one, then your next one, then your next one, and that's it. It doesn't have to care about where you're getting the data. It just needs to know the next value. So let me show you how that works. I've got an HTML file here. So why did I do an HTML not node? Because I just wanted to do it in HTML. And what I'm going to do is I've got a list of animals here that when I press the go button, it's going to get that list. And that list is going to go through each of this really funky looking database and just give me the type, the name, and the classification of each animal. So let's look at our JavaScript file. Here is my database. This is the most awful looking database you'll ever see in your entire life, but luckily each piece of this database does have what we need. It has the type, the name, and the classification. It just sometimes may be right after the first key. It may be inside of one key. It may be inside of 2 different keys, or it may be inside of 3 different keys. And you're going to find out you're going to have databases that are going to could sometimes, you may have to pull data from different pieces of databases, and each one has its own format. And by doing this iterable here, you will be able to normalize the data to be able to, so your application to consume it. And this is how it works. If we go down here, here's our here's our process data. That's going to be our generator. Here is our groups of next, and it's just like the same thing we showed you before. I'm just going next, 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 and I'm just sitting there inserting data into the UL. I mean, that's it. I'm not doing much of anything else. The important thing is what we call the process data. Now, the key here is that, again, we're going to need to be able to interpret all that data that's coming through there and just normalize it to where only thing we deliver is type, classification, and name. So we're going to start off with looping through each one of the different keys in the animals database and just using a simple little for loop to be able to loop through each one of them. And then what I've done here is that there's 4 different styles that I used here. So I just said, hey, case 1, 3, and 7, this is how you're going to be able to get the data. Cases 2 and 8, this is going to get the data. Cases 4, 5, and 9, this is how you get the data. In case 6, that's how you get the data. And that's something real simple there. But the key here is that no matter which one of these that I pull up, my switch statement down here is going to be able to give me just the type, just the name, and just the classification, no matter where it is inside the animal. And then finally, once I have all that data, it's going to do the yield statement after the switch. So what's going to happen is that we're going to do the process data, and again, that will return the generator object, which is the iterator, but it will not execute the function whatsoever, and it won't execute it until I hit the first next. And when I hit the first next, it's going to get to this for loop here, and it's going to start the loop. It's going to do the switch case, and I happen to know the first one is going to do that one. You'll get the type, name, classification, and then it's going to hit the yield. And remember, it's going to suspend the operation of the yield at that particular point in time. So the for loop is still running, but it gets to that very first one, it hits that yield, and that's it. Everything is suspended. I get the type and the name and classification and the done flag sent back to the consumer, which within this little loop here, I will just print it out and then call another next. And then once finally it gets through all of the different keys here, all different 9 keys, it's going to get out of the for loop. And since that's the end of the function, it's going to execute a return, which means the done flag will be set to true, which means this will finally stop executing and we're all done. So we should get a list there, right? Absolutely. Let's take a quick look at that. Let's go to our browser and let's just do a control F5 just to kind of make sure everything is nice and clear. We're going to click on the go button. We should get all 9 of our animals. Bingo! Yes, we got them all. And all we had to do in our consumer is just to say, hey, give me your iterable, then give me the next one, then the next one, then the next one, then the next one, then the next one. I couldn't have cared less of what the data looked like. That was the responsibility of the iterable. So now you see how you can create your own custom iterables pretty much out of everything you want. So why would we even need to ever do that? Well, one of the last things I wanted to show you here, and this is one of the reasons it took me months to figure this out, because I wanted to be able to show you a real life example, is I want to show you a real life example that I guarantee you will encounter within whatever experience within your career that you will have, where using a custom iterable is going to come in mighty handy, and that's next. So let's take a look at our real live application where generators are going to be able to help you. First of all, we're going to show you the wrong way of going about it. I have an HTML file here that represents 3 different applications. And again, this just represents the 3 different applications just for the argument's sake here. Each application is listed out here in its own unordered list. The first application will display all the different types of the animal. The second one will do all the different names of the animal, and the third one will do all the different classifications of the particular animal. So let's take a look at our code. Here is the reader. Now, basically what's going to happen here is that each one of the 3 different JavaScript files to represent our 3 different applications will use this reader class to be able to read in the data. Yeah, I know it's inefficient, but again, this is just for argument purposes here. The purpose of reader is to fetch the data, in this case animals.json, and then to save the data within its data. And what will happen is with both animals1, animals2, and animals3, the 3 different JavaScript files, each one will run the get data. And once it gets the data, it's just going to do a simple little for each to be able to print out the type, the name, or the classification. So in this case, animals1.js will print out the type, animals2.js will print out the name, while animals3.js will print out the classification. Real simple and real quick. So everybody's really fat and happy with this thing. But then upper management comes through and says, well, our database has changed. So here's my first database here. Now the database has changed to look like this. So as you can see, the key information here is now different. So, okay, cool. All right, so we go to the reader. Instead of the reader reading animals.json, we're going to now do animalsother.json. Let's save it up. Let's go over to our browser. Let's do a Control F5 and crash. And why did it crash? And the reason it crashes, very obvious, is that we had our database structure has now changed. So if we go to each and every single one of these applications here, this animal.type isn't available anymore because it's now contained within it's in a completely different structure. So how do you fix that? Well, you'll go to animal1, fix it there, animal2, fix it there, and animal3, fix it there. Great, everything works. Except that management the next week changes the data structure again. And everything breaks. So what happens? Well, you got to change animal 1, you change animal 2, you change animal 3. Everything's working again. And then the 4th week comes through, and for the 4th time, upper management's changed the data again. So what do? You change animal 1, animal 2, animal 3. You can tell what's getting ready to happen here. Every time the data changes, all of these applications have got to change. Well, there's got to be a better way, and there is. And one of those better ways of doing it is by refactoring using the generators. Let's now take a look at that. So you're unhappy, the developers are unhappy, you get them all together, and you sit there and say, look, all right, we're going to refactor one more time, but instead of me just passing you all the data, I'm going to pass you an iterable. And your responsibility is to grab the data from the iterable. And they say, fine, well, why? Well, the reason why is that all now the consumers will have to do is to sit there and just say, give me your next piece of data, give me your next piece of data, give me your next piece of data. And all you have to do is say, here it is, here it is, here it is. So what you do is you define a basic format of how that data is supposed to look like, and you always pass that basic format back to the consumers. So every time they call that next method, as we have seen in previous segments here, is they will always get the exact same type of data that they expect. So once they've refactored, they don't ever have to refactor again because they will always get, in this case, the same data that they expect. But if management then changes their data, all you have to do is change your iterable to reformat the data and just send the exact same data back out to the consumers. Consumers don't have to change a thing. They just keep calling next. They couldn't care less. So management can change all they want, and there's just one thing that has to change, and that's your iterable. So let's take a quick look at that, see how that works. Well, we have our application on the screen here. It's the same thing we've always been using. So let's flip back over to our code. Here's our reader function. And the reader function is just the same as it was before, except now that I have added a generator method. And this is how you do generator methods inside classes. Put the asterisk at the very beginning. And this works exactly the same way as we have seen all the other ones before. Is I've got myself a little loop here that basically tests the length of the data structure, of the data that we've brought in here. And this data that we've brought in, it gets shifted out into the type, name, and classification. And then we yield the type, name, and classification. So that now each of the application developers will know to expect type, name, and classification to come from your iterable. So you go to the developers and say, this is how you now consume it. Let's go to animals1 and take a look at it. So you get to the get data and they say, okay, now all I got to do is just pass, instead of the data like we had before, we just pass the generator object or the iterable. So that iterable is passed, and then it's just a real simple matter of doing the next, the print, the next, the print, the next, the print, until we are done. Just like we have been doing all the other segments. So number 1 here, we'll do the type, just like I had before. Now notice it's within the value property, because remember, when you do the next method on the generator iterable, it will always return a two-property object with value and done. So we're getting it from value. So number 1 gets type, number 2 gets name, and number 3 gets classification. So everybody's happy, everything is working. Now management changes it from our database as it was before to the new database that has the key at the very beginning. So now we have to extract the value of the record instead of just the record itself. So if we were to now come up here and say animals.other at the very beginning, we should expect this to become undefined. And why undefined? Well, the reason it should become undefined, let me just go ahead and bring it up here, is because, remember, we've now changed the data format, but we haven't changed our iterable. And before we had to go to each of the developers and say, hey, you got to change your application. Well, not anymore. Let's flip back over to our code, and let's go into our reader. And now all we have to do is change our iterable. So where before, as you can see on line 24 here, we're yielding the type, name, and classification. Now what we're doing is we're still yielding the type, name, and classification. But what has really changed is how we're getting it. Before, we just got it from the pulling of the shifting of the data off of the stack. Now we're getting the value of the pulled information from the stack. And that allows us to be able to grab the information in this other database, the value here, from each individual record. And that value contains the type, name, and classification, so we are yielding back the type, name, and classification. So the key here is that all we had to do is to change the way we consume the data, and then we're using the yield here to still yield the exact same data back to the application. So now the applications come in. Let's flip back over to our code. Let's save this off. Let's flip back over to our code. Not code, excuse me. Flip back over to our browser. Let's do a Control F5. And we can now read the other database. And did the other applications have to change any of their data? No, not at all. And that is the great beauty of using generator functions. By being able to create your own iterator, there's just so much you can do. And in this real life example here, you don't have to have any of the applications sit there and worry about what kind of data you send to them. That's your responsibility. You just give them the data as they requested. So that's basically the great thing that you can do with using generator functions, and in this case, generator methods. And that's all there is for generator functions. I hope you enjoyed our video. Hope I didn't bore you to death. Please view all of our videos at www.boringjavascript.com. Subscribe to our YouTube channel, or check out everything we have at www.thevirtuoid.com. Thanks again for watching, and we'll see you later.